Hello 8th graders, your new video is from chapter 6, section 1, scientific notation. So we went over this just a little bit last year. I don't think we covered too much, but we're going to get a little more detailed this year. So scientific notation, a number is in scientific notation when the first factor is less than or equal to 1 and less than 10, and the second factor is a power of 10. And you might be thinking, what? If you don't remember what scientific notation is, I'm going to get to it here in a minute. So rule number 1, multiplying a number by 10 to the n power, that's an exponent, when n is positive, moves the decimal n places to the right. Okay, so here's our example. So if I'm going to write 7.66 times 10 to the 6th square kilometers, which is the area of Australia, in standard form. Now, standard form just means write it as a regular number looks. This 6 right here tells me how many spots to move my decimal. It does not tell me how many zeros to add. So I'm going to go 7.66. This tells me 6 spots. So 1, 2, 3, 4, 5, 6. And I'm going to fill in my zeros. And then I'm going to put commas in. So let me rewrite it so that I can fit my commas in there. So it'd be 7,660,000 square kilometers as a regular number. Now, why do people use scientific notation? When they're dealing with really big or really small numbers, it's just easier sometimes to write it in a shortened form like this, as opposed to all of these numbers. Now, this isn't that big of a number. I'd probably just write it out. But when you're talking about the distance from the Earth to the Sun or something like that, I mean, you're talking tons of miles. So then you're not going to want to write out that whole number. So that would be a time when you'd want to use scientific notation. So the other rule, multiplying a number by 10 to the n power when n is negative. So this n is negative today. And we learned how to do that today with the fractions, but we're going to do it with decimals. So it says it moves the decimal point n places to the left. So whatever number this is, this n, that's how many spots to the left it goes. So in this example right here, fingernails grow about 1.23 times 10 to the negative 2 centimeters per day. Okay, well, great. But when I look at this, I'm like, I have no idea how much that is. Is that a lot? Is that a little? I don't know. Write this rate in standard form. So write it as a regular number looks. So I always write out my number, and then you go look at the power here, and that means 2 to the left. So the answer is 0.0123 centimeters per day. Well, that's not very much. So if you look at the spots, tens, hundreds, thousands, 10,000, so 123 10,000ths of a centimeter per day. That's not very much. So here's the next one. To write a number in scientific notation, so if the number is already written like this, as a regular number looks, and you want to change it to scientific notation, you have to put the decimal after the first number, the first, I should add, non-zero number, because you can't just put it after the 0. That wouldn't be correct. It has to go after the first number that's not a 0. And then you write the power of 10 once you find the number of decimal spots that you have to move. And so I'm going to go through one of those right now. So it says write 3,476,000 meters, which is the moon's diameter, in scientific notation. Okay? So I have to write, if you look at this, put the decimal after the first non-zero number. So 3 point. It has to be, wherever you put the decimal, it has to make this number greater than or equal to 1, less than 10. So 3 would be fine. 3.476. Do I need to write these 3 zeros? No. If they're just zeros on the end, I don't need to write it. So then the second part, I have to take it times the power of 10. So how many spots did I move my decimal to get it way over here? So 1, 2, 3, 4, 5, 6. So 10 to the 6th power. So if I took this 6 and I moved this 6 spots, I'd be right back to my original number. That's what this 6 means. So this is this number written as scientific notation. And then let's try one more. So this time I have a really small number and I want to write it in scientific notation. Again, the same rule applies. I have to put the decimal after the first non-zero number. Well, the first number in this one, That's not a 0, it's a 3. So I have to go 3.5 times 10 to the 1, 2, 3, 4, 5, 6. So the -6, because I have to go to the left to get back over where the decimal is actually supposed to be. On this one, I had to move it to the right to get back to this number. So that's why this one is a negative. And again, it's 6 spots, that's why it's -6. Then there's one other type of problem here. So find the value of n. So if I have 1.0035 times 10 to the n equals this, how do I know what the power is? Well, I'm going to count off how many spots. If my decimal's right here, which I moved it to right here, how many spots do I have to move back out to get it to my original number? 1, 2, 3, 4, 5, 6, 7, 8. So my n is an 8. The power of 8 would get me from here to here. So bring that knowledge with you for tomorrow, and we will talk about it more then. Have a good night.